Good evening, everyone. I'm Chamina Sapumohotti, and I'm here to present about the assignment one that we have given for the course Wireless Network Technology. Uh, First of all, this is my content, and today I'm going to present about these topics in this presentation. First, let's see what is a protocol. It is a standard set of rules which is used by electronic devices in order to have a communication between each other. And also within these protocols, it is included about the data type which is transmitting, and these rules are defined at each step in the communication process. And in order to have a successful communication between networks, these rules should be followed. And when we are talking about the importance of standards, the main purpose of the standards is to ensure that the hardware and software produced by different vendors can work together. Also, it provides a framework that enables the devices from different manufacturers to communicate with each other. When we are talking about some standard bodies which are very useful for wireless communication, TIA, the Telecommunication Industry Association, and ITU, International Telecommunications Union, ETSI, European Telecommunication Standards Institute, ECMA, European Computer Manufacturers Association, ANSI, American National Standard Institute, can be taken. And when we are talking about the relationship between IEEE and ETSI, both are collaborating to harmonize brand and 802.11a standards because both operate in the 5 GHz band. And also because of that, ETSI can be considered as the European version of the IEEE. And IEEE standards that are related to wireless communication are as follows. And also, when we are talking about the ISO OSI 7 layers, there are 7 layers, namely physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. I'm going to talk about one layer at each. Uh, it is divided into two layers, the upper layer and the lower layer. And also, in the physical layer, there are some functions: line configuration, data transmission, topology, and signals. In the data link layer, it has functions like framing, physical addressing, flow control, error control, and access control. In the network layer, it has the functions like internetworking, addressing, routing, packetizing. And for the transport layer, it has functions like service point addressing, segmentation and reassembly, connection control, flow control, and error control. For the session layer, it has two functions, namely dialog control and synchronization. And for the presentation layer, it has translation, encryption, and compression. And functions of the application layer are file transfer, access and management, also known as FTAM, and mail services with directory services. This is the layers in the TCP/IP protocol suite. Those layers are application layer, transport layer, networking layer, and the data link layer. Network access layer is the lowest layer of the TCP/IP model, and it is a combination of the physical layer and data link layer defined in the OSI reference model, and it defines how the data should be sent physically through the network. Also, it is mainly responsible for the transmission of the data between two devices on the same network. And internet layer is also known as the network layer, and internet layer is um, it has the main responsibility of to send the packets from any network, and they arrive at the destination irrespective of the route they take. And some protocols used within this layer is IP protocol. Those IP protocols functions are IP addressing, host to host communication, data encapsulation and formatting, fragmentation and reassembly, and routing. Another protocol that is used within the internet layer is the ARP protocol, and it has two terms mainly associated with that. The first one is ARP request and the ARP reply. Another protocol is ICMP protocol, and it also having two terms, that is using ICMP test and ICMP reply. The third layer of the TCP/IP protocol is the transport layer. It is the layer which is responsible for the reliability, flow control, and correction of data which is being sent over the network. And there are two protocols that are being using in this layer: user, user datagram protocol, uh, UDP, and the transmission control protocol, TCP. The last layer of the TCP/IP protocol suite is the application layer. It is the topmost layer, and it is responsible for handling high-level protocols issues of representation. This layer allows the user to interact with the application. Some protocols which is using in this layer are HTTP, SNMP, SMTP, DNS, Telnet, and FTP. And when we are talking about the relationship of ISO OSS7 layers and the TCP/IP protocol suite, we can see that it is through this diagram, and there are some similarities as well as some differences between these two layers. And then we will discuss about the analog and digital signals. Analog signal is a continuous signal in which one time varying quantity represents another time-based variable. In other words, one variable is an analog of the other. And a digital signal is a signal that is being used to represent data as a sequence of discrete values at any given time. It can only take on at most one of a finite number of values. And amplitude is a amplitude of a variable is the measure of how far and in what direction that variable differs from zero. Thus, signal amplitudes can be either positive or negative. And frequency is the rate at which current changes direction per second. It is measured in hertz, an international unit of measure, where 1 hertz is equal to 1 cycle per second. And a phase involves the relationship between the position of the amplitude crest and trough of two waveforms. Phase can be measured in distance, time, or degrees. If the peaks of two signals with the same frequency are in exact alignment at the same time, they are said to be in phase. So, then I am talking about how to find a bandwidth of the signal. The bandwidth of a signal is defined as the difference between the upper and lower frequencies of a signal it is generating. The bandwidth of the signal is equal to the difference between the higher or upper frequency and the lower frequency. And when finding the maximum allowable bit rate, it depends on three factors: the bandwidth available, number of levels in digital signal, and the quality of the channel. It means the level of noise. When we are talking about the noiseless transmission media, we can use the Nyquist bit rate to find the maximum allowable bit rate. And when we are talking about the noisy transmission media, we can uh, use the Shannon capacity equation to find the maximum allowable bit rate. And some impairments are explained in the next slides. So the noise is a random and unwanted signal that mixes up with the original signal. And there are several types of noise such as induced noise, crosstalk noise, thermal noise, and impulse noise, which may corrupt the signal. And another impairment is the distortions. Distortion means changes in the form or shape of the signal, and this is generally seen in composite signal made up with different frequencies. And each frequency component has its own propagation speed traveling through a medium, and that's why it delay in arriving at the final destination. Another impairment is attenuation. It means a loss of energy. The strength of signal decreases with increasing distance, which causes loss of energy in overcoming resistance of the medium. This is also known as attenuated signal. Amplifiers are used to amplify the attenuated signal, which gives the original signal back and compensate for this loss. And another, when we are talking about, then I'm going to talk about the PCM process. It is PCM means the pulse code modulation is a method used to digitally represent sampled analog signal. In a PCM stream, the amplitude of the analog signal is sampled regularly at uniform intervals, and each sample is quantized to the nearest value. Then I'm going to talk about some two low rate encoding methods. The first one is the linear predictive encoding, in short LPC. It is a method used mostly in audio signal processing and speech processing for representing the spectral envelope of a digital signal of speech in compressed form using the information of a linear predictive model. And it is one of the most powerful speech analysis techniques and one of the most useful methods for encoding good quality speech at a low bit rate and provides highly accurate estimates of speech parameters. It is the most widely used method in speech coding and speech synthesis. The second encoding method is modified discrete cosine transform, shortly MDCT. It is a lab transform based on the type 4 discrete cosine transform with the additional property of being labbed. It is designed to be performed on consecutive blocks of a larger dataset where subsequent blocks are overlapped so that the last half of one block coincides with the first half of the next block. Then I am going to discuss about the error detection in block coding. If the following two conditions are met, the receiver can detect a change in the original code word by using block coding technique. The first one is the receiver has a list of valid code words. The second one is the original code word has changed to an invalid one. The sender creates code words out of data words by using a generator that applies the rules and procedures of encoding. Each code word sent to the receiver may change during the transmission. If the received code word is the same as one of the valid code words, the word is expected. The corresponding data word is extracted for use. Then I'm going to talk about the error correction in block coding. Error correction is much more difficult than error detection. In error detection, the receiver needs to know only that the received code word is invalid. In error correction, the receiver needs to find or guess the original code word sent. So we need more redundant bits for error correction than for error detection. Then I'm going to talk about cyclic code and checksum. Cyclic code. In coding theory, a cyclic code is a block code where the circular shifts of each code word gives another word that belongs to the code. There are error correcting codes that have algebraic properties that are convenient for efficient error detection and correction. These cyclic codes have some additional structural constraint on the codes. They are based on Galois fields, and because of their structural properties, they are very useful for error controls. A checksum is a small-sized block of data derived from another block of digital data for the purpose of detecting error that may have been introduced during its transmission or storage. By themselves, checksums are often used to verify data integrity but are not relied upon to verify data authentically. The procedure which generates this checksum is called a checksum function or checksum algorithm. Depending on its design goals, a good checksum algorithm usually outputs a significantly different value even for a small change made into the input. Then I'm going to talk about the transmit buffer and receive buffer. The function of the transmission buffer is to keep the output rate of the encoder fixed. If the buffer starts filling up faster than the transmission rate, it sends a message back to the transform coder to reduce the output from the quantization. The TCP receive buffer is how much data can be buffered on the recipient's end. Normally, a TCP stack will not allow data to be sent if it has no room for it in its receive buffer. Then I'm going to talk about the importance of flow control. Flow control is important because it is possible for a sender to transmit information at a faster rate than the destination can receive and process it. This can happen if the receiver has a heavy traffic load in comparison to the sender, or if the receiver has less processing power than the sender. Then here are some information about the HDLC protocol. HDLC protocol stands for High Level Data Link Control, and it is a bit-oriented code transparent synchronous data link layer protocol developed by the ISO. The standard for HDLC is ISO ICE. It provides both connection-oriented and connectionless service. It can be used for point-to-multipoint connection via the original master-slave modes, normal response mode, shortly NRM, and asynchronous response mode, ARM, but they are now rarely used. Then I'm going to talk about CSMA/CA protocol. It is known as Carrier Sense Multiple Access with Collision Avoidance. It is a network multiple access method in which carrier sensing is used. To deal with collisions, carrier sense multiple access with collision detection is for collision detection, every node monitors the bus while sending data. If the data on the bus is different to the data a node is currently sending, a collision is detected. Then I'm going to talk about the MAC layer. The MAC layer is responsible for moving data packets to and from one network interface card to another across a shared channel. Different protocols are used for different shared networks such as Ethernet, token rings, token buses, and WANs. Then some details about LLC layer is given. Uh, the logical link control sublayer provides the logic for the data link layer, and it controls the synchronization, flow control, and error checking functions of the data link layer. Also, it acts as an interface between the media access control sublayer and the network layer. It provides multiplexing mechanisms that make it possible for several network protocols to coexist within a multi-point network and to be transported over the same network medium. Then I'm going to talk about the IEEE 802.3 MAC frame structure. It is a basic frame format which is required for all MAC implementation is defined in this standard. This is the structure of this one. It has preamble, SFD, known as the start of frame delimiter, destination address, the source address, length, data, and CRC means the cyclic redundancy check. And I'm going to talk about some architectures including AP, BSS, and ESS. AP means access point architecture. uh, Device that contains IEEE 802.11 conformant MAC and PHY interface to the wireless medium and provide access to a distribution system for associated station. Most often infrastructure products that connect to wired backbones. And basic service set, also known as BSS, is a set of stations controlled by a single coordination function. And a BSS can have an access point or can run without an access point. Extended service set, also known as ESS, it is a set of one or more basic service sets interconnected by a distribution system. And traffic always flows via access point, and the diameter of the cell is double the coverage distance between the two wireless stations. And I'm going to explain about the IEEE 8.802.11 MAC layer. It lays down the architecture and specifications of wireless LANs, and users connected by WLANs can move around within the area of network coverage. And it is responsible for encapsulating frames and describing frame formats. The main fields of a frame wireless LAN as laid down by are frame control, duration, address fields, sequence, data, and check sequence. Two coordination functions for collision avoidance before transmission are: the first one is the distributed coordination function, and it is a mandatory function, and also it is used in distributed contention based channel access. The second one is the point coordination function. It is an optional function and also it used in centralized contention free channel access. And this is the end of my presentation, and thank you for listening.